we're just waiting. There we are. Hello and welcome to GigaOm Live. I'm your host, Johnny Baldisberger, and I'm joined today by analyst Enrico Signoretti and Jason Collier. Hey guys.
Hey Johnny, how you doing?
Now, this is an interesting week. Now, I hate to break the mold going straight into a new thing, but technology, we don't stand still. We never stop moving. Specifically, this week we're doing it a little earlier than we plan to do them in the future, because we are smack dab in the middle of Tech Field Day 23, and both of you are attending virtually, as unfortunately every event has been for the last year and a half. But I really wanted to I didn't want to miss a week, and I thought Tech Field Day is a big enough thing that we should talk about it, and give you guys a chance to kind of tell our audience what's been going on, what are the highlights of what you've seen so far before you have to go in for, I believe it's your final day of Tech Field Day today, right?
Yeah.
Okay, so let's just get started. Enrico, I found out about Tech Field Day because of you, so why don't you start us off and kind of tell us something that's really caught your attention and been an interesting aspect of this year's event.
Yeah, so there are 2-3 companies that really stand out for me at this event, and there is a common topic that comes out very often, which is CXL. We will talk about this later, but I think CXL is something that could radically change how we design the future data centers. And in practice, this is a technology that allows to extend the PCI bus and connect resources organized in pools. So you have not only CPUs, but trays with full of RAM, GPUs, or FPGAs, or many other things like SSDs, persistent memory. Think about any sort of component that you can have attached to a PCI bus in a server, so practically everything. And instead of having a single unit, so the server, and everything is contained and static, so you buy the server and that's it. You can modify the configuration, but it's still static. You have to order a component, put it in the server, and reconfigure it. Okay, so it takes time, it's not really efficient, etc. With CXL, everything changes because you have your data center organizes in racks full of these components, and you just pick what you need. You can configure and program them, and you have different servers, different compute units or storage units that work for the time that you need them, and then you can reconfigure them and change the entire configuration of your cluster. So the potential is huge from efficiency point of view, performance point of view, etc., etc. So one of the companies that presented this technology was Micron, that is very, very focused on the next generation of its product enabled by this technology. So there is a lot going on in their research around CXL. So they showed us what is the potential roadmap. So that's really, really exciting. I don't know, Jason, if you had something to add on Micron and their presentation that was really compelling from my point.
Yeah, the Micron is kind of one of the they're going to be a very important piece in making all of this work. And really, what that CXL is, it's kind of this cache coherent interconnect between the processors, memory expansion, and then the accelerators, kind of like you mentioned. And one of the interesting things is, like, they've already come out with kind of the 2.0 draft of CXL, and it's going to be dependent also upon PCI Gen 5. So it kind of runs over that PCI Gen 5 bus, which is, there's a reasonable amount of bandwidth there. And it's even going to, one of the things in 2.0, CXL 2.0 that they introduced was switching. And one of the interesting things when you talk about composability and composable infrastructure, it's going to be, from a Micron perspective, it's going to allow you to share memory across different hosts, different actual server mechanisms in a data center. So when you're talking about this kind of real composable infrastructure, I think this is going to be one of those key parts of that full composability stack, where you've got literally the ability to address memory across multiple machines. And also share the cache coherency with a lot of the accelerators. I mean, one of the biggest issues I think we're seeing, and you see everything kind of, rear its ugly head in high performance compute, initially, because they're trying to solve problems most people aren't. But then a lot of the innovations that happen in high performance compute have a lot of uses, within the broader data center. And I think one of the things that CXL is going to enable is solving a lot of these complex issues in high performance compute, that then is going to translate down to what is going to be a standard way of doing application development in enterprise as well.
Yeah, totally.
But yeah, Micron for doing like memory sharing across the machines. I mean, that's going to be huge, and that's kind of what the 2.0 spec with the switching is going to enable.
Excellent. And for you, Jason, what's really stood out to your attention over the last couple of days? What's kind of really blown you away?
Honestly, so how pervasive CXL has gotten in literally the span of a few field days, right? And the specification's been out for a while, but we also saw, Xilinx as a company, and Xilinx has their new SN1000 based smart NICs, and a big part of what they were talking about, as well as what CXL is going to enable from the fact of how much offload can be done at a smart NIC level. So, one of the things is like their future generations are also going to be CXL enabled, where that smart NIC, and we're talking, these are like 100, gigabit NICs that they're shipping today. And then there's literally an offload engine that has an ARM processor that's got 8 gig of RAM in the ARM processor, and then an FPGA, which can be, for fully programmable gate arrays, which are really good at solving specific types of high performance compute problems. So these problems can actually be solved, kind of directly on the NIC itself. So it doesn't even make it to the CPU, right? So when you've got these, distributed issues, but then it also does a lot of things for accelerating networking, right? And, making that, getting near line rate on a 100 gig connection. And one of the big parts, once again, from the HPC perspective, is you can process all this data, but a big issue is like ingest. How quickly can you get that into, like a GPU to do compute on it, the FPGA to do compute on it? So one of the ways in which, Xilinx is doing it is by basically putting the FPGA directly onto the NIC itself. So you can actually use it for, solving hard math problems, right? Directly on the NIC without ever making it to the CPU. And the more you offload from the CPU, the more it can process other things, right? So running the general purpose compute within that node, while the very specific, say parallelized workloads, matrix workloads, from like TensorFlow and things like that, you can actually, kind of push those off to those other accelerators within the system. So that was pretty cool to see how Xilinx was actually kind of, adopting this as well, and that, really CXL just popping up, at this Tech Field Day, being one of those really kind of transformative technologies.
I'm going to pull the curtain aside for our viewers for just a second. We have a shared doc online that we kind of fill out through the week, and so we have an idea of what we want to talk about on Friday. And in Xilinx, there is a comment: accelerators in general are hot. And then beneath that, XCL again, exclamation point, question mark, exclamation point. So, CXL is really kind of hitting the hammer hard this Tech Field Day.
Yeah, I have to add that, even if you talk about FPGAs alone, they are, interesting. I mean, they showed an integration with Ceph, for example. So they can offload a lot of storage operation directly on the NIC. And this, of course, a lot of advantages because you can use, less expensive CPUs to do the work, or you can have, faster system or more dense systems, or, flash system that can work, with a better efficiency. So these NICs can really give an advantage to the user. I mean, depending on how you can use them, they can really change the way you design your storage solution in this case. But again, they can be used in several ways, so they can be programmed, and it's way easier than in the past. I mean, I thought that programming FPGAs, I mean, was something like one thing that you do in the lab and that's it. Okay, and it's very difficult to reprogram it. But actually, now you can program it with C, C++, P4, so generic languages, and you can add your software in these cards. So it's not as complicated as it was in the past. So it's probably that many you can use tools like AI frameworks and stuff like that, and maybe just adding the FPGAs and having the right components already backed for you, you can take advantage of them without really programming the FPGA itself. So there are a lot of routines that are now ready. There are a lot of functionalities that are open source. So you just put the code in your program and you compile it, and you can have the optimization for the FPGA done. So it's really powerful. I mean,
one of the things is Xilinx showed that I really liked. Ivo, the CTO, was up there, and he kind of showed the evolution of how the programming over the last 20 years in FPGAs has changed, right? Like pretty much from you had to be like a hardware level programmer doing stuff in assembly to pull anything together, and now it's down to the high level languages where you can actually write this code, have it translated, and run on FPGAs. I remember seeing FPGAs. One company I remember in particular, they were acquired, I think it was back in 2011, but it was Blue Arc. And you may remember them, Enrico, from a storage perspective. Yeah. They had a really fast NFS server, and what they did is like they literally coded an entire NFS v3. I don't remember if it was v4, but I think it was v3 server, and put it on an FPGA, right? So you're effectively running an NFS server instead of a CPU running code and translating a lot of this stuff. It's literally running it on hardware. And they were, able to get an insane amount of IOPS over NFS, back at a time where, there was no systems or CPUs capable of pushing it that fast. But, it required a lot of, that was a lot of, intellectual property at the time. And now you can basically recompile it, which is what they did with Ceph. And, Enrico and I, we were kind of, hinting at it a little bit, but, I think you and I both want to build one of those things in the lab, get some of the Xilinx cards and run a Ceph cluster, that basically doesn't hit the CPU.
Yeah, exactly.
That'd be interesting.
That would be very, very good. Also, because you can think about, Ceph in the particular case. So you can have the object store based on Ceph, and on top of it, a serverless computing framework doing stuff directly on the objects. So you can put, your code very close to the data in this case. I mean, without doing anything more than recompiling your Ceph or optimizing Ceph for doing more stuff. So it's much more efficient than moving stuff around in the network, in the data center.
Yeah.
So let me take a step back. Actually, I want to talk about the actual event itself, Tech Field Day. Who gets to decide what is actually shown? Is it vendors just spending money so that they get a seat at the table and a showcase? Is it more about showing what's new at your company, or is it about unveiling new technology? What's the purpose, and what drives incredible analysts like Enrico and Jason to attend these events? Because Enrico, you write reports, you write blog posts about these events throughout the year. You always attend them and always have a lot to say about them. What makes Tech Field Day such a standout as far as these events go?
Well, first of all, there is the community behind it. I mean, it's not just the event itself. Stephen Foskett, the organizer of Tech Field Day, did a great job in pulling together a large community of practitioners across the world. And for me, it's not only having the opportunity to talk directly with vendors, and sometimes there are startups, they need some visibility, so they are eager to talk with us and everything. But there are also, the ongoing discussion in private channels where you get a lot of information from people that are in the field every day. They use the technology. Sometimes they use the technology we talk at this event. So it's you get a real feedback of what is happening, why it is happening, and things like that. So from my point of view, it's not only what you see live. I mean, probably for the vendor, the most important part is what you see live, and the interaction on Twitter and social media in general. But for me, it's a broader experience. I mean, and it is pretty cool. I mean, it's very valuable, and so this is also why I write often about this event, because I think that everybody in the IT industry should somehow participate as a delegate or as a vendor when presenting. I mean, it's a good opportunity for everybody.
Yeah, and I've got so a little bit of my perspective on this is I started out presenting at Tech Field Days as a vendor, right? And there, I'm going to give a little bit of a vendor pitch for Foskett here on why this is valuable for the vendors to actually sign up and do this. So my company, Scale Computing, at the time, one of the things that we were having struggles with was the fact that what we were trying to differentiating it, like we were very technologically differentiated, but when you look at it from the 10,000 foot view and you look at it from the surface, you're like, how is this different from company X, right? And one of the things that Tech Field Day is strip all of the marketing fluff out of any type of vendor presentation that you've ever seen and get down into the core technology and how it really works, because that's where a lot of those differentiating components are for a lot of the companies out there. You're going to see there will be a dozen companies that when you look at their website, you're like, these guys all sell the same thing. And when you really dig into it, each one of them does it in a different way. And those technological ways in which they do it could make the complete difference in a customer implementation, right? So the customer is looking for a specific thing, but the way this company solves it and the way this company solves it, could be two dramatically different ways, which are going to impact, the customer's business. And really what Tech Field Day allows vendors to do is get down into, like, this is how we built it. This is the underlying architecture. This is the structures. This is where it's a good fit, right? One of the things that I do wish vendors would kind of take more out of this is like talk more about specific customer use cases and the problems that they are fixing for those customers and how they're fixing them, right? And the vendors that do really well at Tech Field Day grasp that. They say, hey, we're good at solving problems for this customer, not for this customer, right? This is our niche. This is where we're really good. But it's a lot of the stuff you don't necessarily get from the marketing fluff on the website. And really what these events do, and I mean, one of the things that we would do, these are all then kind of parsed out into videos. We can pop them up on YouTube. And then whenever somebody, and these are always the questions that would get asked during a sales cycle, like, oh, how's this done? We're like, watch this 15-minute segment of Tech Field Day, and this is going to explain everything you need to know. And, we honestly use that to eliminate sales objections because it gave us stuff that we could point at. So we didn't have to spend more time like educating the customer on these things that we had already put out there. So that was really valuable for us in Tech Field Day.
So, a couple of things I'm going to touch on. First, I think marketing fluff is the bane of all sales, personally. I understand why it's there, but it gets in the way of you actually addressing the customer's needs. but that's my personal gripe. I was in sales for a long while, and the key to success, in my opinion, is knowing which customers need which product. Don't try to sell everything to everyone, because you'll end up losing a customer when they realize you're just trying to fill your pocket. But that said, you mentioned getting into the nitty-gritty and differentiating companies. Now, GigaOm has a way we do that. Specifically, we have our GigaOm radars. Now, I talked about this a little bit last week, but this was, you mentioned, you brought it up. I really want to kind of dig into that because we had a bunch of radars go live this week, specifically about object storage. So I wanted to take this last, 5-10 minutes to talk about object storage, touch on these radars. Both of these reports were written by one of our rockstar analysts. Great guy, does fantastic work. He's blushing right now, but Enrico, you wrote both of these reports. The GigaOm radar for evaluating enterprise object storage, and the GigaOm radar for evaluating high performance object storage. So let's two-part question. First, why is object storage a hot topic? And second, why are these two different radars?
Well, I think that the answer to these two questions can be a long single answer. I mean, so object storage changed radically, and we saw, at the early 2000, the first implementation, and then the Amazon S3, everything was about eventual consistency, was about, having a very slow storage mechanism, but cheap enough to store data that is not accessed for a long time. So archiving workloads, okay? And other workloads that needed to, other sort of, large files that you have to keep for quite some time, but you don't really touch it. I mean, compliance, even a secondary backup repository for long time retention, even if it's not archiving, maybe you can keep this data for a long time. So things are, changed a lot. I mean, in maybe in the last 3-4 years. So with the adoption of object storage for new workloads, and lately with Kubernetes, a lot of new applications use object storage as a primary storage to store persistently data. Okay, and also data growth that we are always talking about adds to this, more interactive workload. So you're storing more data, you are accessing data frequently, but you don't want to do it with the traditional methods because they are too expensive. Object storage is also more accessible from the internet. Is based, the access protocol is based on HTTPS. So there are several reasons for which object storage became more relevant for enterprises in general. And of course, the cloud was one of them, but again, more workloads, more analytics, more everything. Okay, so we changed our perspective from every primary and secondary storage with the idea of having primary and secondary data. And when you start writing data in an object store, but it's your primary data, okay, it becomes probably more important for also from the latency point of view, for the performance point of view, not just from the fact that you don't want to lose it. So this changed the paradigm, and now we have still traditional object storage that can do yes, some performance, but actually they are not designed for performance. They are just designed for capacity and dollar per gigabyte. While there is a new generation of object store that are more and more focused on performance, latency, high-speed transactions, and next generation technology, including Kubernetes and stuff like that. So this is why we decided to split the market in these two radars. Of course, consider that from my point of view, okay, in the long term, there will be a shift of traditional object storage. Actually, this is already happening. They will become more and more similar to high performance object storage. At the same time, high performance object storage today are not, they are not complete in the terms of the feature set sometimes. So you will see a grow in the number of features, and so they will try to become more traditional from that point of view. So this is why. So everybody is concentrating more workload. They are doing more with object storage. Backup software now can use object storage as a primary target, so more interactive workload than in the past, and more application use object store, more analytics like Splunk. Everybody wants to make the example of Splunk and object storage, okay, because Splunk is one of the biggest sources of data creation in many companies. So people love Splunk. They use it for everything that is analytics now. So in log analytics and probably everything analytics. I mean, that you can put in something like this. So that's the idea. So more interactive loads needed, faster object storage. Not everybody was ready to do that. Actually, most of the traditional objects that were not ready. They're working to do it, but at the moment we have two different categories.
That's what we were kind of discussing with customers needing to get into the nitty-gritty to understand exactly what they need to answer their specific use cases. Jason, I'm sure you have a plethora of things to say about that. However, I'm not going to let you. We are close to our time, and we have published a lot of research. I say we. Enrico has published a lot of research this week. We took the key criteria for evaluating Kubernetes data storage live this week. We had a solution brief from David Linthicum on delivering the promise of SASE, which was sponsored by Juniper Networks. We had the GigaOm vendor profile for OS Nexus, which is related to object storage, I believe high-performance object storage. The GigaOm radar for high-performance object storage actually went live this morning at 8 a.m., and the GigaOm radar for enterprise object storage, which I believe is the second version 2.0 of this particular report, went live earlier this week as well. So lots of new research.
But I have to add, if I may, that not all of it is from me. I mean, now we have a storage team at GigaOm, so that
yes, Max Mortiero and Arjan Timmerman are part of your team. I'm still asking for an intern from our boss, and he continues to say that if I have an intern, I'll just sit on my couch drinking Mai Tais while they do all the work. He is not wrong, but I believe that's beyond the point. So we have a lot of new research, and yes, as we move forward, more and more, our analysts are working with teams so that we can ensure that we get a wide view, lots of different perspectives, and as much expertise as possible jammed into every report to help those who subscribe to our research. Because at the end, our goal is to provide relevant, important research for people to make smart decisions. With that, guys, we are out of time. Sorry, Jason. I know you didn't get to flap as much as you would have maybe liked to.
I'm good.
Don't
worry, I make up for it on other ones.
Yeah, he has a call scheduled right after this, and he is not going to let the other people talk. With that, we're out of time. Thank you, Enrico, Jason, for joining me today. Jason Collier, you can be found on Twitter at Bocanuts, Enrico at eSignoretti. Both of those are down in the corner there. You can, of course, find us at GigaOm on Twitter as well. You can also find us at GigaOm.com, where you can read our blogs, sign up for our webinars, listen to Voices in Innovation podcasts, or subscribe to our full body of research. You'll get the full breadth of reports we've written, not only on object storage, but written by an incredible, diverse team of analysts on an incredible, diverse spread of topics. For all your future forward advice, GigaOm.com has you covered. Thank you, everyone, and have a great weekend.
Ciao.